Hi everyone, this will be your video for how to find arc length of a circle. So we have a fairly short and simple little equation we're going to be using here. And when we're talking about arc length, we're going to be using theta in radians, so our angle measure should be in radians, not degrees. And we're going to be able to find the length of our arc. So I'm going to highlight that for us. It's basically this piece of the circle that this angle would provide for us. So that's our arc length here. So we have our equation, it's S equals R theta, so it just means you're going to take your radius times your angle measure in radians. So here's our first example. They're giving us our radius, they're giving us our angle measure in radians, and they're asking us to find the arc length. So what I suggest, even though this looks like a word problem, let's take our values out. So we can say R equals 4. We can also say that theta equals 5 pi over 4. We can always rewrite our equation here, so S equals R theta. And we know we're going to take our R, which is 4, times our theta, which is 5 pi over 4. Now this one's pretty clear and easy to see that these 4's are going to cancel. You have a 4 being multiplied by your 5 on top, and a 4 being divided by that 5 on the bottom, so they'll cancel. You could also just do 20 over 4. So we end up with 5 pi as our arc length. Alright, so here in our second example, we can see that now we're using our arc length to find the angle measure. So we can always use our arc length formula to find our radius or our angle measure depending on our given information. It's not just for your arc length. So here they're giving us some information. They're saying that S is 11 because that's our arc length. They're telling us our radius is 5 and this is theta. So one thing that you can remember from earlier on in this video is that this is in radians. So when we do solve, we're going to solve for a value for theta, and that would be in radians. This problem is asking us to answer it in degrees. So see here, I'm highlighting it. It says to the nearest tenth of a degree. Alright, so keep that in mind for the next few steps. When we're solving for theta, you can just divide by 5. So we get 11 over 5 to equal theta. So 11 over 5 reduces to 2.2. Now remember that this is in radians, and that's what our theta equals. So what we need to do is just now convert from radians to degrees. This is in the video titled Degrees in Radians. So we have 2.2 radians, and remember that's what we have. So when we're writing our conversion factor, that means we're going to have pi radians in the denominator. We want this unit to cancel, and we want our angle measure to be in degrees. So when I'm doing this, I do my 2.2 times 180, and I get 396. I'm going to write that below. 396 over pi radians, and what that's going to equal, we can just type that in. We're going to divide that by pi, and we get 126. And they're asking us, I believe, for the nearest tenth. Yep, so the nearest tenth, so we'll have 126.1 degrees.